All right. Good afternoon, guys. So yesterday we have seen STP spanning tree protocol. So complete one day we have let it go for STP. So today we will see Ether channel. We'll see port security and also another topic. We'll see. Okay. I'll extend your batch to next week also, if possible. 1 or 2 days max. That is enough. So now today the concept we are going to see is Ether channel. Write down for Ether channel. Write down for Ether channel under STP domain. Under STP domain to get faster convergence. Under STP domain to get faster conversion between switches. Faster conversion between switches. Minimum 2 trunk port. Minimum 2 trunk port. And maximum 8 trunk port. And maximum 8 trunk port become one virtual port. Become one virtual port. This is called Ether channel. Under STP domain to get faster convergence between switches, minimum 2 trunk port and maximum 8 trunk port become one virtual port. This is called Ether channel. Right on next point. It is used to combine multiple physical port to a single logical port. Simple definition. It is used to combine multiple physical port to a single logical port. And what are the advantages of it? Write down. Increases bandwidth. Next point, redundancy. And cost. That,
Reduces bandwidth or increases?
yeah, it reduces their expense, obviously. If it's increase the expense, why I'm going to choose?
No, bandwidth.
Bandwidth, yeah, it increases the bandwidth as in like lot of data can be sent. More data can be sent. Okay.
Is my voice hearing?
What?
Are you able to hear my voice clearly?
No, not clearly. It's very
Okay.
less.
Low.
Yeah,
Okay.
very low. Yeah. So I have two switch. Okay. Okay. So this is my switch one. Switch two. Oh, no chair. They put all in that classroom. That's why. Switch two. Lift Bahubali. So we have switch one and switch two. Correct? So see, in real time, we are not preferring, we don't use just one or two links. We'll have multiple links. Okay. Because with one link, what if that link goes down? Then we can't connect to the internet and all. So every time there will be multiple links connected. So here I'm connecting with 4 links. So all these 4 links, right? They'll be acting like a one link. That is Ether channel. Okay. All the 4 links we are making into a one link. That is Ether channel. Okay. So there are 3 modes in it. How many modes? 3 modes. First one is PAGP. That is port aggregation protocol. and it is a Cisco proprietary, and it combines up to 8 links. And it works on desirable and auto. Where did you learn this desirable auto?
DTP.
DTP, very good. So if it's desirable on one side and other side also desirable, it will work. One side desirable, one side auto, it will work. Auto, it will not work. Here it works. Here also, either channel works. But auto, it will not work. Okay. This is one mode. Other mode, LACP, that is link aggregation protocol. And it is a open standard. It combines up to 16 links, but only 8 link will be active. And it works on active and passive. Again, active it will work, active passive it will work, but passive it will not work. Okay. And third mode is static. Here we say it as on mode. So both the sides it should be on. Written this. Now we'll see the practicals for it. Okay. So I'm having 3 things. Here I'm going to do PAGP. Here I'll do LACP. Here I'll do static. Okay. First, I have to make every port as trunk port. Okay. So if I have to make trunk port, I can go to this switch and say switch port mode trunk so that other side will become trunk. Likewise, here I can do. Likewise, here I can do. Instead of what I'm doing, I'll go to this switch and I'll say interface range 1 to 6 become trunk so that all the switches will become trunk. So interface range, we have 0/1 to 6. Correct? Switch port mode trunk. So everything will become trunk. So I'll go to this switch. Say host name PAGP. Okay. Interface range of 0/1 to 2. Okay. One command that is you're going to give us channel group 1 mode active. Done. I given active. Now this is again same thing. Interface range of 0/1 to 2. Say channel group 1 mode. I'll say active. Port is up. So ether channel summary. Oh, I given active. Instead of PAGP, I said active passive. What is active passive? So this side I'll do LACP and this side I'll do PAG. Okay. I said active passive. Active passive comes on LACP. Desirable auto comes on PAGP. Okay. So here you can see what is the port? Port 1. That means two ports are taken as 1. And what is the protocol used? LACP. What are the ports? F0/1 and F0/2. Likewise, multiple links you can make it into a one link. So how does it affect STPC? See, you see it as one port. Okay, you see it as one port. So what happens is if there are like three switches like this, yesterday's topology you can take 1, 2, 3. Okay, in that case, what will happen? So if you're having 8 links, 8 links, 8 links, so all the 8 link here it will be blocked. There also all the 8 link will be taken as designated port, and they'll share the information in each and every link. That is how your ether channel works. So this is your PAGP, and one more command is there. Show ether channel. So how many ports we have binded together? 2 ports. What's the maximum ports you can bind? 16. Okay. See, one maximum port channel is 16, but only 8 will be active at a time. That is your LACP. So protocol used is LACP. What group I have used? Group 1. Likewise, you can see the details. So you have two commands. One is show summary. Other one is show ether channel. Now this side I'm going to do PAGP. Same command. Like I said, in your switching concepts, there is like lot of commands. No, all are only basic level commands. Okay. So interface range F0/1 to 2. Sorry. Yes, 1 to 2. Channel group Range is 1 to 6. Here I'll say 1 again because this side I haven't created any group. So I'll say 1. I'll say desirable. Channel group 1, more desirable. Okay. Now go to this switch. Interface F0 slash 3 to 4. Range. Correct. Channel group 2. Because 1 already there in this switch. That's why I'm giving 2. Okay. What is the more? Desirable. Interface range F0 slash 5 to 6. Correct. Channel group 3. More. You have desirable on passive. So I'm giving static on. Done in this switch. This switch is also done. Go to the switch. F0 slash 5 to 6. Sorry. 1 to 2. New switch, right? Correct. I'm saying channel group 1. Saying mode is on. Done. Show do you see any protocol here? No. That means what? It is static. And show ether channel summary if you give. You can see here what are the ports binded and they are in static and there is no protocol used. Let us come to this switch and say, see if you give exit, you'll go to global mode. Again, if you give exit, you'll go to privilege mode. I'll say end. Directly you'll go to privilege mode. Okay. Show ether channel summary. So here you can see what are the ports binded in LACP, PAGP, and then static. So it will be taken as one port. Though I have two ports, it will be taken as port 1, port 2, port 3. Likewise, it will take it. Okay, this is your ether channel, a basic level. In your NP class, I will teach which link it will choose. So this data, if it is sending from this PC, which link is it is going to send? Which link this it will send? That we will learn in your NP. Okay. All right. Any other doubt? You want the comments? So what sort of questions will be asked in ether channel? They'll ask you what is ether channel, why it is required. Then you say, what is ether channel means? It is multiple physical ports are combined into a single logical link. Why? To send more data, reduce the cost. If one link goes down, other link will be still there, active, so that the redundancy is also there. This will be the answer for you. And they'll ask you what are the modes. So PAGP, LACP, and static. So they'll ask you to explain the things. So PAGP is Cisco proprietary. Up to 2, maximum 8 links can be active at a time. Whereas in LACP, 16 links can be there, but only 8 will be active at a time. And also static mode on. This much is there in your CCNA level. Okay. All right. First, you have to make the trunk. Write down these things and also show ether channel. One command and another one is show ether summary. So first one is what? This one is trunk, that is normal. Here it is LACP. This is PAGP. This is static. Write down. Written, guys. Okay, write down, write down.
Sir, that is LACP or LAGP, like
Link aggregation protocol. LACP. Link
GP.
aggregation control protocol.
Okay. The other thing GP only.
LACP. Link aggregation control protocol. Sorry.
Control. Okay.
All right. Mhm. So that is Cisco proprietary. This is open standard. Only Cisco devices support PHP. Cisco, then it will work. Depends on your budget. Depends on company's perspective. If company is able to afford Cisco devices, they'll go for Cisco devices. If not, they'll go with other vendor and they'll use open standard. Huh? I can't hear you. Hmm. What is the best? Best practice? What do you mean? I don't see. If you want, see, if one side is Cisco, other side is different device. Okay, then you have to go with only LACP because that is open standard. Both Cisco device and other vendors will accept it. Only PAGP you will have to go with Cisco device. So one side if you are having Cisco, other side is other different vendor. Both will do LACP. That is the preferred one, and that is the only option. Otherwise, you can go with static, but it is good to go with LACP because at a time you can have 16 links. Okay, written. Next topic is your port security. See, So this is my trusted PC and this is untrusted PC. Okay. So this is my server. This is my trusted PC. I'll give IP here. One dot one dot one dot 100 default subnet mask. Here I will give 1.1.1.1 subnet mask. Okay, fine. Now will this PC be able to ping the server or not? Yes or no? Yes. I'm getting a reply. This is fine. Okay, this is my topology in my organization. So server is there and I'm connected within the network. What if I want to manipulate something inside the organization? What if I bring my own laptop? Okay, and I'm going to take this link and leave it here. See, what is the other way we can do this? What another way? I can simply connect another port, right? That is the easiest one. I can simply connect it like this. But the problem is that ports, they'll make it shut down. So if you want to connect, then you have to go to that switch, get the access, and then you can make it unshut and so that you can get the access. But you don't have the access of switch. In that case, you can't take another link. Yes or no? You can't, right? No. So what you are going to do, what I'm going to do, I'll just plug in this link. Okay, unplug it from my trusted PC. I'll plug it on untrusted PC. Now I'll try to ping. What? Why? Is P this one given IP? Okay. Ah, sometimes this packet reset does this, but okay. It's pinging now. So now what happened? I was able to access the server, correct? With my untrusted PC. And now I can do anything. Do anything as in I can check what is the connectivity is there, what is the IP of the server, MAC address I'll come to know, which I don't want. In that case, what I'm going to do is I'm going to do the port security. I'm going to do the port security. See, one more thing he can do. What he can do means, see, he can bring one more switch. Okay. And he can place it here between this and take this link, connect it to it. So it is connected by F0/1. And now you will take link. You'll take another cable, you'll connect it like this, you'll connect it like this. Now what will happen? This switch is connected to the trusted port only, but other switch, it is connected with trusted and untrusted. Now again, you'll be able to ping. Correct. Again, you'll be able to ping. So you can't stop it now. So that is the reason we are having this port security concept. Okay. We are having port security concepts. Inside port security, we have three modes. Okay. Write down these things. Port security. So we have shutdown action. We have three actions. One is shutdown. Under shutdown, write it down. It is a default violation mode. It's a default violation mode. Written. Next point. If violation occurs, if violation occurs, if violation occurs, the port will move to air disabled state. ERR. Air disabled state. In bracket, you can write it down as shutdown state. Written. So first, it is a default violation mode. Next point, it is if violation occurs, the port will go to a air disabled state, that is a shutdown state. Next point, write down. Even authorized PC will not have access after violation. Even authorized PC will not have access after violation. Even authorized PC will not have access after violation. Next point, logs will be generated. LOGS, logs will be generated. Next point, to bring up the port up, the admin has to manually, to bring up the port up, the admin has to manually shut down and to bring up the port up, the admin has to manually shut down and no shutdown to bring the port up. Written. Logs will be generated to bring the port up. The admin has to manually shut down and no shutdown to bring the port up. Next mode is restrict. If violation occurs, the port will not go down. If violation occurs, the port will not go down. Unauthorized, next point, unauthorized PC will not have access. Unauthorized PC will not have access. And unauthorized PC will not have access. And authorized PC will have access. Next point, logs will be generated. Logs will be generated. Okay. Third one is protect. Protect is same as your restrict, only one point is different, that is logs will not be generated. Other than that, every point is same as restrict. Logs will not be generated. Written. Okay. Now, in your CCNA, we'll discuss this shutdown mode. Okay. Now I'm having this untrusted PC, that is 1.1.1.1. He's able to ping the server, that is fine. Now I don't want this untrusted PC to ping this server. So how I'm going to do it? So here comes your port security concept. . Okay. So first say show port security interface F0/1. What is the violation mode by default? Shutdown. And port security is disabled. Okay. Now we are going to enable it. Before that, go to this PC. Go to config, fast Ethernet. Copy this MAC address. We are going to secure it through MAC address. Now go to this PC. First say interface F0/1, switch port mode access. Okay. And then you're going to say switch port security. Now I have enabled it. So do show port. Now it is enabled. Initially it was secure down. Now it is secure up. Okay. So interface F0/1, switch port security, and then give MAC address. Switch port security, MAC address, MAC address, and then paste it. Okay. Switch port security, MAC address, this one, enter. Okay. Now go to this PC. Able to get the replay? Now same link, I'll put it on untrusted PC. Will I get the replay or not? No, because I have filtered the MAC address. I said only trust this port, this MAC address if it's coming from this port. I said interface F0/1 and only trust the MAC address which I've given. So other things it is not going to accept it. Can you see the port has went down? Now if you go and ping, even he will not be able to because port is already down. So if someone, for example, you know this army and all right, if army, those they are having the secret documents. So what if someone tried to get the documents inside the army itself? So when they try to take the plugin and they put it on their own PC, and if they try to, get the access of server, at that time it will go to shutdown mode, and even he will not be able to open it through his trusted PC. Then the admin will come to know, okay, somebody tried to manipulate it. Then they'll start the inquiry and accordingly they'll find it. So this is a shutdown mode. Okay. Another thing is there. Before that, you can just write it down these things. And to check it, say show port security. Show port security interface F0/1. Now I've bind the MAC address manually. Correct. Next one, I'll show you how to do it dynamically through the shutdown state itself. Written? Everyone? Okay. Now I have another scenario. Okay. One dot three. Okay. This is 1.4. Okay. This is 1.5. One dot six and 1.7. Okay. Like this, if I'm having four, this is connected to 5, this is connected to 6, 7 is connected to 7. Okay. Like this, if I'm connected. So I have multiple PCs in my organization. Okay. Every time I don't want to go and give the MAC address dynamically. Sorry, statically. Instead, I'm going to do it dynamically. That means, so in my office laptop, this is my office laptop. I have a system in my office, correct? What system you will use? You will use that system only. So you're not going to change that system. So I don't want to do it statically, but I want this PC only to be allowed. For that, only one command is there. Very simple command. That is, first say interface range F0 slash 3 to 7. Interface range F0 slash 3 to 7. Okay. Here, I'll say switch port mode access. I'll say switch port security. I will enable it first. Then I'll say switch port security, MAC address. I'm going to say sticky. Okay, one command is there, sticky. If I give this sticky, what will happen? If I'm trying to ping from PC3 to server, okay, first time I'm going to ping, so it will take this MAC address as the trusted MAC address. Next time I'm going to ping from PC4. First time I'm pinging from this 4 link, that is F0 slash 4. So that link, it will take it as trusted. Now, see, I'll first try to ping it. I'm able to ping. Did I give any MAC address filtration? No. Now, this is my So this is my untrusted PCs, these two. So what I'll do, I'll take this link, I'll keep it here, connect it. Now I'll go and try to ping. ping 1.1.1.100. Is he able to ping? No. He'll not able to ping because of the command sticky. So it has taken this PC3's MAC address as the trusted MAC address because it has been trying to ping it for the first time. Same thing works on this also. See, the port has went down. Can you see? So this is the another one mode in your shutdown mode. So now I'll try to ping from this PC4. It's pinging. Here also it will ping. Yes or no? Ping. Ping. But the problem is, if I drag this and leave it on my untrusted PC, and if I try to ping from here, your port security will not allow to ping. See? Understood. This is dynamically doing it. That is, whatever the PC which is trying to ping the server for the first time, it will take that PC as the trusted PC. Okay? Just you can.
So what if that trusted PC before the trusted PC sends the this one request to the ping to the server? Untrusted PC.
So in your office laptop, which first you're coming to the office. So initially what you'll do, you'll use the system only, right? Directly you can't use the untrusted PC. If that's the case, then untrusted PC will be taken as the trusted PC. In that case, you can't help it. Okay. But they will already be, the communication will be happen from trusted to server. Then only they will give you the laptop. Okay. So in that case, it is not possible. You can just write down only one command, this one. That is enough. You know the meaning, right? For sticky.
Sir, in this, only the first PC will be considered as trusted, and new PCs will be untrusted, like that.
Oh, I didn't get your question.
Only in this sticky when you're giving
Yeah.
the first, only the first PC will be taken as trusted, and all the new PCs will be untrusted,
Yeah.
like that.
Yes, that's
Here.
the concept. Yeah.
Okay, okay. Just to verify.
Okay. All right. That is the concept.
Okay.
Written? Everyone? Okay. So this is your port security. Okay. Now I'm going to teach you something important called inter-VLAN routing. Write down inter-VLAN routing. Write down when multiple IP subnet communicate on switch. When multiple IP subnet communicate on switch domain, with the help of L3 device. With the help of L3 device is called inter-VLAN routing. When multiple IP subnet communicate on switch domain with the help of L3 device is called inter-VLAN routing. Next point, if this procedure is configured on L2 switch, this procedure is configured on L2 switch, it is called router on a stick. Router on a stick. stick stick. And if this next point, if this procedure is configured on, L3 switch, then that is called SVI, switch virtual interface. Written. When multiple IP subnet try to communicate on switch domain with the help of L3 device is called inter-VLAN routing. That means, see here, I'm having two PCs. Okay. So I'm going to change the IP. This side I'm going to give as 10.1.1.1. Here I'll give 11.1.1.1. Here I'll give 11.1.1.10. Sorry, 20 I'll give. Here I'll give 10.1.1.10. Okay, like this I'll give. This is the virtual IP. I'll just keep it like this. Okay. And now, what I'm going to do, this is a different IP. This is a different IP. So here I'm going to configure as VLAN 10. VLAN 10. And here it is VLAN 20. First, I'll assign the IPs. Okay. Okay. Now go to this router. Before going to router, I'll create the VLAN in switch. Enable, configure terminal, host name, switch 1. Okay. So interface F 0/1 belongs to switch port access VLAN 10. Correct? Okay. Now creating VLAN, access VLAN does not exist, creating VLAN 10. So VLAN 10 has been created. Now I'll say interface F0/3 switch port access VLAN 20. Okay, this side is 10 and this side is 20. Now they have to communicate via F0/2 only here. Correct. F0/2. So that should be in trunk mode because different VLAN. 10 is communicating to 20. So the packet will go to the router and then it will come. So that's why I'm making it as trunk there. Understood? Now come to router. Hostname R1. So interface gig 0/0. I'll make it no shutdown. Okay. And then, see, I'm not going to use this physical interface. How many physical interface? Only two. Or if you add one more, then you will have three physical interface. I don't want to use the physical interface. Every time you can't use that. Instead, I'm going to use the logical interface. That is sub interface we say. Okay, we say it as sub interface. Where we are using the sub interface? In the inter-VLAN routing when you try to communicate with different IP subnet. Okay, see, I'm going to say interface gig 0/0. Okay, dot. Give the question mark. See, these many sub interface you can make in one interface. Okay, this we are using it for the inter-VLAN routing. So I'm going to say dot 10 because of VLAN 10. Okay, and the state is already up. Okay, because it is logical. After that, you have to say no shutdown. Just if you want, you can say it, but its state is up. Sometimes the packet tracer will not work. So I'm saying no shutdown. And then encapsulation dot 1Q. That means this trunking protocol is going to carry the VLAN information. We have ISL, inter-switch link, and then encapsulation .1q. We are using this .1q, reason being?
8 bits.
Exactly. Because of what bits?
8 bytes.
No. Your ISL is a 30-byte header. This is a 4-byte header. 26-byte header is more in your ISL. Okay. After this, I'm going to say the VLAN number. What is the VLAN number? 10. Enter. Okay. And now I'm going to add an IP. IP address 10.1.1.10. Done. Now I've created a sub interface gig 0/0 dot 10. Now I'll say interface gig 0/0 dot 20. Okay. Then I'll say no shutdown. Then encapsulation .1q VLAN number 20. So 20. So IP address 11.1.1.20. Done. Correct. Okay. Now, excuse me. Did I give the gateway? No. So I will give the gateway 10.1.1.10. Did I give any physical IP? No, I did not even configure it. 20. Correct. I'll go to this PC and say ping 11.1.1.1, right? What is this PC IP? 1. See, we are able to ping from one subnet to different subnet without using the physical IP. So 11.1.1.0 is what? Different network. 10.1.1.0 is a different network. But if they ask to communicate, you can use this inter-VLAN routing with the help of L2 device and with the help of L3 device. If you're doing it under switch L2, then that is router on a stick. If you do it with L3 switch, that is switch virtual interface. Okay. So any doubt on your router on a stick? Why we are giving this command, that command? Any doubt on those things? First, initially what you're doing, you're giving the IPs on the PCs. Okay, that is fine. Two different subnets. Then you're going to the switch. In the switch, you have 3 ports. So one port you're saying this belongs to this VLAN, this belongs to this VLAN. That means you're creating the VLAN first. After that, the port which is going to the router, you're making it as trunk because you have to communicate to different VLAN. If you want to communicate with different VLAN, you need trunk port. Access port will not work. Correct? And then going to the router, you are doing the routing there. You are doing inter-VLAN routing. That means we are doing the routing on sub interface. How we are giving the sub interface? Interface gig 0/0 dot. Then give the number, random number. Any number you can give. I'm giving 10 because of VLAN 10 so that it is easy to configure. And then you're saying encapsulation .1q .10 because to carry the VLAN information, you need a trunking protocol. So that's why I'm giving that encapsulation .1q. After that, I'm giving the IP. Okay. Understood or not? Any doubt on online, guys?
Sir, can you paste like this? Can you once copy this and
What?
no, can you just copy in notepad and paste the
Yes,
comments?
that I will do, right?
Yes,
I'm asking, did you understand the concept or not?
yes.
Yes. Okay. What about others?
Yes.
Yes. First, make the physical interface up. See, here you can see configure sub interface. Can you see? Yes.
Sir, hello.
Yes.
Sir, can you say on that encapsulation dot one Q
Yeah.
once more?
So we have two VLANs. We are communicating between VLAN 10 and VLAN 20. If it's an
Oh,
access port, will it work or not? No. Why? Because
no.
access port carry one VLAN information. Between 10 to 10, you can communicate. 20 to 20, you can communicate, but you can't communicate with different VLAN. If you want to communicate with different VLAN, it should be in trunk port. So the trunking protocols are what? ISLN dot 1Q.
Yes.
You can use either one. Here I'm using dot 1Q because even Cisco devices are using dot
Yes.
1Q only because of the header size. Okay?
Yes. Correct.
Hmm.
That IEEE 802 that only, right?
Yes, yes, that is the one.
Oh.
Write down the comments written, everyone. Done. So in switching, see today we have already seen EtherChannel, port security, inter-VLAN routing. See, three concepts we have seen in one day. Correct? That means in switching we are having lot of small topics. Lot of questions are asked in inter-VLAN routing. What is router on a stake? What is which virtual interface? Why we are using inter-VLAN routing? What is inter-VLAN routing? What are the commands of it? Why we are giving .1Q command there? Okay, why we are using sub interface? What is sub interface? So all questions there might be asking you. Any question out of this. No.
Interfaces. Then you use for inter-VLAN or
This
something.
only for inter-VLAN routing. Okay, written. Okay, right. You don't have to write this config, this thing and all. Just write SW and write hashtag. Put the hashtag and you can write. Written Mohammed. Write down. What is your name? What is your name?
Balaji.
Balaji. Oh, you're Balaji. Between you did not attend few classes, right? Did you go through the videos? Okay, Mohammed. Okay, next thing we are going to see is switch virtual interface. That means we are communicating with the help of L3 switch. So same thing, I will give 10.1.1.1, 255.255.255.0. Then I'll say 10.1.1.10. Here 11.1.1.1 or 20 also. Okay. Now I'm going to use this L3 switch. You can use this switch. Okay. Connect it like this. Okay. Our IPs are there. Now go to the switch. See here, one difference you will see. It will ask for yes or no, like a router. Because it is a L3 switch and it is capable of doing routing. Interface F0/1. Correct? F0/1. I'm going to create the VLAN 10. Okay. And then we have F0/2 VLAN 20. So two VLANs I've created. Now I'm going to assign the IP. How I'm going to assign the IP? Interface VLAN 10. On the VLAN interface I'm creating, not on the physical interface. Again, I'm saying interface VLAN 10. I'm saying IP address 10.1.1.10. Done. And then interface VLAN 20. Dot. Done. After this, one command, extra command you have to give. That is, you have to say IP routing. Then only it will do the routing. Otherwise, it will behave like a switch only. Okay. Now ping to 1.1. So now you will get 100% reply. Here also I'm using the, which one? The logical interface. Interface VLAN I'm using, not the physical interface I did use. I say interface VLAN and I did the routing. This is with the help of L3 switch. Okay. We can do the inter-VLAN routing. This method is called what? Switch virtual interface. Never forget this IP routing command. If you forget this command, then you will not be able to do the practical. Written everyone? Okay. So what we have discussed today, Ether channel, 3 modes, code security, shutdown mode, and then we have seen inter-VLAN routing, that is router on a stick and switch virtual interface. Okay. Time is there, we'll see one more topic also. Is it too much? Yes or no? We'll see one more topic or we'll have an interview. I'll give some time, you can prepare on topic and then we can have interview. What? Did you come to class yesterday? Be honest, tell me how many of you want one more topic or how many of you want interview? Okay. Raise your hands, those who want interview. Raise. Okay, we'll see another topic. So now we are going to learn. I thought too much practicals on one day is not good. That's why. FH RP. That means see, if I'm having a topology like this. This is my PC1, PC2 connected to a switch, PC3 and PC4 connected to a switch. This switch is connected to a router like this. These routers are connected to ISPs. Okay. This is ISP, router 1, router 2, switch 1. This is PC1, PC1, PC2, PC3, and I have PC4. Okay. We are having 4 PCs and switch is connected like this. Okay. See, there is 2 options. Okay. So if I am having all these 4 PCs, I am giving the gateway as R1. Okay. Then what will happen? Every packet will go via R1. Correct? Yes. So what if this R1 goes down? Will I be able to get the access of network? No. Will I be able to reach internet? No. So complete network is gone down. Correct? What is another scenario we can do? So R1, for example, if the IP is 10.1.1.10, okay? And for R2, 11.1.1.10, like this I'm keeping. Okay. In this scenario, what I can do? Or simply I will say 10.1.1.20, like this I'll say. Okay. In this case, for this two PCs, I can give dot 10. For these 3 and 4, I'm giving dot 20. So if 10 goes down, is the entire network down? No. The other two PCs can communicate to the internet. Likewise, if 20 goes down, only 3 and 4 will go down, correct? 1 and 2 still be able to access the internet. But the entire network is not up. That is the problem. If one goes down, I can access the internet, but my entire network is not up. So that I can't afford in my real time. So what I'm going to do is, between these two, I'm going to create a virtual IP. I'm going to create a virtual IP. Okay. So that this virtual IP, I'm going to give as the gateway in all those 4 PCs. So all those 4 PCs will have gateway as 100. Okay. Like this, I will give the gateway so that it will first initially it will go via R1. What do? I'll configure the redundancy protocols as well. Meanwhile, so that all it will go via R1. But once this R1 goes down, immediately it will go via R2. So that is actual redundancy. So that the network will never go down. Understood? So it will be going via R1 and I'm not giving dot 10, dot 20. No, not giving either of those. I'm giving the virtual IP, which is configured on both the routers. And they will communicate between each other through multicast address. If this goes down, he will come to know, and then immediately he will become active. The other will go standby. Okay, so that is your redundancy protocols. Understood the concept? Yeah. Any doubt on concept? Okay. Tomorrow we are going to learn translations. We'll see the practicals tomorrow. Today we'll discuss the theory of this one. Okay. Write down FHRP. Under this we have HSRP, VRRP, and then we have GLBP. This is First hop. Write down these things. Before that, what is FHRP? Let me explain you. FHRP means first hop redundancy protocol, and it is used to prevent network failure at the default gateway. That means if one router goes down, the other router will come up. Where? In the default gateway. So it is used for that redundancy purpose. Okay. And this is achieved by configuring multiple routers with the same IP address. That is virtual IP, thus preventing an illusion of single virtual router to the host. So I'm not using the physical IP. Instead, all the routers I'm going to assign with the virtual IP, and that virtual IP will be given as the default gateway. Because if you give physical IP, then the packet will go via physical IP, which I don't want. Okay, so that's why we are creating multiple routers with same IP address. Same IP address as the not the physical IP, virtual IP. Okay. So IP address of the virtual router is configured on all hosts in that network and subnet as their default gateway. Correct? So all PC1, PC2, PC3, PC4, all will have the 10.1.1.100. That is the virtual IP as the default gateway. Okay, this is how it works. So we have multiple FHRP protocols. What are the protocols? HSRP, VRRP, and GLPP. Write down these things. See, now that your DTP, VTP, STP, almost your this thing is over. Your switching is over. Correct? Yes. Okay, tomorrow I'll tell you. Yes, tomorrow I'll finish translations also. Hmm?
Syslog and then
Syslog is like 2 minutes concept. We're not explaining much here. SNMP syslog we are discussing, but very in a small thing. Written this. Okay. Now I'll give you some theory. You can write it down. So in HSRP and VRRP, there is a active standby pair. That means at a time. That means at a time, only one router will be in the active state and will be forwarding the traffic. So in HSRP, the active router is known as active, and then backup router is known as candidate. Okay. Sorry, backup router is not candidate. Backup router is known as standby. Right. Okay. If more routers are configured for redundancy, they will be known as known as candidate. Next point, in VRRP, the active router is known as master and the routers are known as backup. So HSRP is a Cisco proprietary protocol. VRRP is a open standard. Okay. We have another thing, that is GLBP is also a Cisco proprietary protocol. So in GLBP, all routers are in active and forwarding state. See, your HSRP and VRRP are almost just the same. Okay, there's no much difference. That means one goes down, other will come on. This is Cisco, this is open standard. But whereas GLBP, at a time there can be multiple routers that can be active and they can carry forward the information. At a time, multiple routers can be active. That is GLBP. Okay, that we will learn in your CCNP. Okay. After that, for FHRP, yeah, virtual IP is configured on all the routers. So this virtual IP is configured on the end host as their default gateway. Write down this. Everyone written? So we are having HSR under FHRP, we have HSRRP, VRRP, and GLBP. So in your CCNA, we are covering only HSRRP as per syllabus. VRRP and HSRP are just same. Only one command we are saying. In your HSRP, we are saying standby. In your VRRP, we are saying VRRP itself. That is only one command change. Other than that, everything is same. In your VRRP. But GLBP is little different. That we'll see in NP. So as of now, HSRRP, that is active standby pair. One is active, other one is standby. Whereas in a VRRP, master, backup. Okay. So once if this router goes down, automatically other router will come up. Okay. So that practical, there is election criteria and there is one small practicals for it that we will do tomorrow. So this is the basic theory part. Okay. So tomorrow we'll do that practicals and we will see what is static NAT, dynamic NAT and PAT. And we'll do the practicals of all those three. So tomorrow we are having 4 practicals. And after that, the translations and switching is completely over. We'll go to DHCP. That is Thursday. So DHCP will see what is DHCP, relay agent and snooping. And DNS, after that, 2-3 classes, your CCNA is over. So major part will be over by day after tomorrow. That is by Thursday. Major of your CCNA is over. Okay. Any doubt on today's class online, guys?
Clear, sir.
Clear. Okay. Thank you. I'll see you guys tomorrow.